We look at angles. And angles, by definition, we can define an angle as the amount of turning at a given point. And angles are different types. And types of angles that we all know is a right angle, triangle, straight angle, reflex angle, and obtuse angle, including the complete oval revolution, which adds up to 360 degrees. Today on angles, we'll talk about a complementary angle. What are complementary angles? Complementary angles, these are two angles. When you sum up, they give you 90 degrees. They're similar to the right angle triangle. The two angles, when you add them together, let's take, for instance, this is actually our A, and this is our B, and this is our C, and this is our D here. If this angle here, maybe let's say this is 45, 43 degrees, and this angle is X here. These two angles are complementary angles. The two angles should sum up to 90 degrees. Now, how do we find the value of X? Now that we're dealing with complementary angle, we can say that our X plus 43 degrees is equal to 90 degrees. For us to find the value of X, which represents an angle, at that point, we'll do this, we'll say X is equal to 90 degrees minus the additive inverse of 43 degrees, crossing over the equal sign, it is negative 43 degrees. Therefore, we say our X is equal to the difference between these, it will be 47 degrees. So 47 degrees represents X, such that when you add these two, 43 plus 47 degrees, we're going to have 90 degrees, of which we are only getting 2 points, 2 angles to add up to this, to get a complementary angle. So when you add the two angles, it must give us 90 degrees, which is a complementary angle. So now let's look at supplementary angles. We've been talking about complementary, now let's talk about supplementary angles. Supplementary angles, the two angles, when you add them together, they should give you 180 degrees. We say that a straight line angle, which is 180 degrees, and supplementary angle are similar. Or can say they are one and the same, because they add up to 180 degrees. Now, we have a question here. This is a straight line. AD is a straight line. And here there's a line which divides the line of the line where there's y and there's 180 degrees. This is an indication that these two sides, when you add them all together, you should get 180 degrees. And there's a number or an angle which represents y, such that when you add the two angles together, we should get 180 degrees. So how do we find the value of y? If we are saying that the two angles sum up to 180 degrees. So what we're going to do there is, we simply say y plus 130 degrees is equal to 180 degrees. Then we know from here we'll say the additive inverse with like terms there, this is an equation. We're simply going to say that y is equal to 180 degrees minus 130 degrees. Thereafter, we'll say that y is equal to the difference between 180 and 130 degrees is thus 50 degrees. So y is equal to 50 degrees. So where there's y here, there's a 50 degrees there. Such that when we add these two angles together, we're going to find that this angle is 150 degrees. When we add the two angles together, we're getting 180 degrees. So the emphasis here is that when you're dealing with complementary, we're talking about 90 degrees. The two angles gives 90 degrees. When we talk about supplementary angles, the two angles, when you add them together, you should get 180 degrees. Yeah. Wait, let's look at another question to see how you can answer it. Suppose the question consists of two parallel lines inclusive of a transverse line which cuts the two parallel lines. We are told from the beginning that when two lines are cut by a transverse line, corresponding angles are formed. Alternate angles are formed. And how do we tell these angles are corresponding angles? They form an F shape. Let's look how we can answer the question. Letter A. How can we find letter A? Which angle does letter A represent? In short, that's what the question demands us to find. When you look at this shape very well, when you look at it so clearly, you will find to say some of the answers that we have there, we have them around. It's kind of a card, it's a smart game that we're trying to play here within the letters, and we'll see how best we can locate the answers within here. When you look at the solution for the first one, A, how do we find A? Angle A is corresponding angle, it's corresponding to this angle here, 130 degrees. 130 degrees and this angle here are the same. Because there's an F shape made, even there's an F shape made there. This F shape we're making here, and even here is an F shape made. So angle A is equal to 130 degrees. These are corresponding angles. Corresponding angles. Let's look at letter B. Looking at letter B here, this angle here. When you look at this angle and this angle here, these angles are vertically opposite angles. This angle B and 130 degrees are equal to each other. So angle B is 130 degrees. We say vertically opposite angles. Let's look at C. Now, looking at C here, this is a straight line, remember? And from talking about a supplementary angle, we said a supplementary angle is a situation where we have two angles summing up together to form 180 degrees. Those two angles make 180 degrees. For us to find C, we simply say C plus 130 degrees is equal to 180 degrees. So we say our C is equal to 180 degrees minus 130 degrees. So C will be equal to, the difference there will be 50 degrees. So at this point here, this angle is 50 degrees. C. How do we find the angle at D? Very easy. The angle at D can be found also. This is a straight line, remember. These two angles sum up to 180 degrees. They're also supplementary angles. We said supplementary angles, these two angles sum up to 180 degrees. So A and D is equal to 180 degrees. So we simply say our A plus D is equal to 180 degrees. My A is corresponding to 130 degrees. I'll substitute there, hold it place. Where is A, I'll put 130 degrees. Plus D is equal to 180 degrees. Thereafter, I'll say OD is equal to 180 degrees minus 130 degrees. OD will be equal to 50 degrees. This angle here is 50 degrees. And here we said this is 130 degrees. Those two angles should give us 180. Even this other side, these two angles, in future, they should give us 180 degrees. Altogether, there will be angles at a point summing up to the complete revolution, which is equal to 360 degrees. So now, having found D, how do we find E? E is equal to 50 degrees, because this angle and this angle are vertically opposite, are equal to each other. So meaning that I'll say E is equal to 50 degrees, and the reason behind it being 50 degrees is because they're vertically opposite angles. How do we find F? We can only find F. This F can be found by adding the two also. We can say F, either we add the two to get 180, or we can say this 130 and this 130 here. These are two angles. Angle A and angle F are vertically opposite angles. Meaning that if the answer for A is 130, even the answer for F also is also 130 degrees. So F is equal to 130 degrees, also vertically opposite angles. Lastly, how do we find F? Z, Z, don't forget, in the first place we said this angle and this angle are the same. Same applies to also this C here, this angle 50 degrees, even there is 50 degrees. So we say Z is also 50 degrees because they are vertically opposite angle to C. So Z is equal to 50 degrees, which is vertically opposite angles. We can bring in also the idea of the alternate angles, which an alternate angle where a transverse line cuts the two parallel lines, where we form an alternate angle which makes a Z shape. This Z shape here, meaning that this angle and this angle must be equal to each other. If this angle is 130 degrees, this angle and this angle must be the same. If this angle is 50 degrees, this angle and this angle must be equal to each other. They are making a Z shape, and these two angles are alternating angles. So we can specify that in the question in other ways. But this is how we can solve such a problem. Thank you. So let's look at one way of how we can solve a question which involves a triangle, involving angles right there. Our discussion is just inside the shape, where we found angles and also a letter at A. Now, we want to find the value of A. Now, this type of a triangle is what we call a scalene triangle. A scalene triangle is a type of a triangle which has no equal sides, which has no sides equal. And the angles inside the triangle are different, are not the same from one another. You can see this is 90 degrees here, this is 36 degrees, and the other angle here wants to be 36 degrees. How do we find the angle at that point? Remember that the sum of the sum of the angles inside the triangle is equal to 180 degrees. The angles inside the triangle sum up to 360 sum up to 180 degrees. The angle at A, the angle at B, and the angle at C. When you add all these angles together, you are going to get 180 degrees. So we will substitute that. The first one, it will be x plus, we have a 90 degrees, plus we have the angle which is 36 degrees, is equal to 180 degrees. Thereafter, we'll say that our x plus, we add the two, we're going to have 126 degrees is equal to 180 degrees. Thereafter, we'll say that our x will be equal to 180 degrees minus 126 degrees. Our x will be equal to, we look at the difference between those two, which we're going to find to say, when we subtract those, we're going to have here 10 minus 6 on the other side. It's going to be 4. And then we'll have 7 minus 2, which is going to be a 5 on the other hand. So the final answer will be 54 degrees. So at this point here, we have 54 degrees as our answer. So 54 degrees represents the value of x. So the value of x is equal to 54 degrees. The only proof that we have that when you add all the angles inside the triangle, we should get 180 degrees. So this is the way you can answer such a question, if at all you come across this question during the final exam. Yeah, still on angles. As we discussed today, the types of triangles that we have. Not only these, there are other types of triangles that we will not talk about looking at what is in the syllabi this time around. We will discuss the 3 types of triangles and their properties. The first type of a triangle that we'll discuss is a scaling triangle. A scaling triangle is a type of triangle which has no equal sides equal to each other. The sides are not equal to each other, in short. And as well as the angles are not equal to each other. An example of a shape of a scaling triangle, it can be this way. This is the triangle we have here. Meaning that the angles inside the shape are not equal to each other. And as well as the sides of this, the triangle has 3 sides. From the word 3 means 3 things. Now, the 3 sides are not equal to each other. This side and this side and this side don't have the same units. They have different units in terms of measurements. When you get inside the triangle there and see very clearly there, you will find that this angle at this point and this angle here are not the same, as well as this angle which is 90 degrees. So we can describe in short that this is actually a scaling triangle, where the sides are not equal to each other, as well as the angles inside the triangle are not equal to each other. But the truth of the matter here is the sum of the angles inside the triangle must add to 180 degrees. Let's take a look at isosceles triangle. Isosceles triangle is believed to be a shape, a triangle, which has the 2 opposite sides equal to each other. What do I mean? Let's look at the shape. This simply means that the sides are equal to each other. If one side is 4 centimeters from that vertex, even the other side, it must be 4 centimeters. And even two angles which are opposite to each other are the same. If this shape is associated triangle, if one angle is 40 degrees, even the other angle is 40 degrees of the opposite side of the triangle. But bear in mind that the truth of the matter about this shape is that the three angles inside the shape must add up to 180 degrees. The two sides are equal to each other, except the other side here are not the same. It's different. The two sides are equal to each other. This can be 3 centimeters. Lastly, as we discuss about the equilateral triangle is believed that it's kind of a shape which has all the sides equal to each other, and this is how the shape looks like. The amazing point about the equilateral is that all the sides are equal to each other, as well as the angles are equal to each other. If all the sides are equal to each other, meaning that every angle of this shape is equal to 360 degrees. Each angle is 60 degrees, and there is 60 degrees, even there is 60 degrees. As long as it is equilateral, meaning that each angle is equal to 360 degrees. If we're saying this is how it is, how they found out this is the degrees. If they say, let's take for instance, say we have one common letter which is A. Let's say each angle has been given A. So A plus A is equal to 180 degrees. Meaning that the coefficient of the letters here is 1. When I add the ones by 3, or you multiply by 3, you will still get 3A here, which is equal to 180 degrees. Divide by 3, my A is equal to 60 degrees. 3 goes into 180, 60 times. So this is the angle of every point of a triangle. So each side of the angle of equilateral is equal to 60 degrees. So, in conclusion, in an exam, they can ask any of these, and we should understand the properties. That this one, all the sides are not equal, as well as the angles. This one, 2 sides are equal, as well as the angles. 2 angles are equal. These ones, all the sides are equal, and all the angles are equal to each other. And each point of the angle is equal to 60 degrees.